In this video, we're going to take a look at how to use our periodic table to determine the number of protons, electrons, and neutrons, so the subatomic particles found within different types of atoms. So just a quick overview before we begin. Here you can see the periodic table with all the elements, and you can see an example of an element just zoomed in here. We can take a look at mercury, Hg. You can see that the element is represented by its symbol rather than its name here. And over here we have its name. Not all periodic tables will have a name written down. Some will, some won't, but they'll always have that symbol. And you'll see there's a whole bunch of important numbers here. And those numbers are what we're going to use in order to figure out different things, different characteristics, or different items about that element. So again, here's our periodic table. We can see all the elements there. Remember that an element is a pure substance that can't be broken down to anything simpler by physical or chemical means. So it's really that smallest Lego piece that we have that's possible. And there's different types on the periodic table, for example, carbon, oxygen, hydrogen, gold, helium, so on and so forth. There's 118 elements. 92 of them are natural and 26 are synthetic, so made in the lab. They're not really found in nature because they're too unstable. And what I want you to understand is that in the periodic table, if you were to look at the box for an element, you would notice a symbol. And the symbol could be either one letter or two letters to represent that element. And the reason we use a symbol rather than the name all the time is because the symbol is universal. So, regardless of what language you speak, every scientist would understand that I is iodine. They might say it differently as a word, but overall, I is iodine, or hydrogen is H, or potassium is K. So again, the words are different. So I might say in French hydrogène or idrogeno in Italian, or hydrogen in English, but when we see H, it means the same thing to everyone. So symbols are universal. They could be one letter or two letter. If it's one letter, remember that one letter has to be uppercase. You cannot have a lowercase letter for your element symbol. And it can be two letters as well. If it's two letters, remember that the first letter, for example, calcium, is uppercase, the C, and the second letter is lowercase. You can't have, first letter lowercase, second letter uppercase. You can't have first letter lowercase, second letter lowercase. So those are not permissible. You need to make sure your first letter is uppercase and your second letter is lowercase. So do make sure you do recognize that. And you might not think it makes a difference, but it does. So for example, if you were to write CO, carbon monoxide, versus CO, little o here, that's the cobalt element. This is the compound carbon monoxide. So again, here we have more examples of symbols. We have the sodium element symbol has two letters. First letter is uppercase, second letter is lowercase. And you'll probably notice that in the word sodium, there's no N and there's no A. So why did we choose NA? And that's because the symbols are based off of Latin words. Same thing with potassium, K, silver, Ag. Those are all based off Latin names, which is why the symbols don't often seem to make sense, but they do if you know what the Latin name is. So you can use your periodic table to figure out a whole bunch of information about the element you're trying to study. So here is just a zoom in of a box from a periodic table for a particular element. In this case, it's for oxygen. You can see we have the symbol that we can determine. We can also determine the atomic number. We can also determine the mass number and also the name. So the symbol, like I said, that's that universal symbol that tells us what the element is, one letter or two letters. The atomic number is typically at the top somewhere. You just have to make sure you read your periodic table legend. It'll tell you where the atomic number is generally, but it's usually at the top in your periodic table. And that refers to the number of protons, actually. So your atomic number also tells you your number of protons. And if the atom is neutral, it's also the number of electrons. Also number of electrons. Number of electrons. And your mass number is essentially how much the atom, let's just say, weighs by mass. How heavy is it? And this mass number is made up of two parts. It's made up of the protons and the neutrons combined together. Combined together. Remember that the electrons don't contribute to the mass because they're very, very light. They're negligible. So really the mass number is made up of protons and neutrons. The mass number is usually at the bottom of the square in the periodic table as opposed to the top. And if you're ever confused, generally the mass number is going to be larger than the atomic number that you see there because the mass number is not only your atomic number, your number of protons, but it's also the number of neutrons in there as well. And so suppose you want to find the number of neutrons, you could take your mass number and your atomic number and essentially take away your atomic number from your mass number and you get number of neutrons. So for example, in the case of oxygen, we know the mass is 16. And we know that mass comes from the number of protons and the neutrons together, added together. We know that there's 8 protons from the atomic number, so we know that 16 is equal to 8 plus number of neutrons. We don't know what that is, but if you think about it, 8 plus n, must n be to be 16? Well, n must be 8. Or you could just do some math there. You could do n is equal to 16 minus 8 if you rearrange that equation there, and you get 8 neutrons. So you can find all your subatomic particles using the information in your periodic table. We're going to do some examples together. So we've kind of already done this, but just to walk you through it, here we have a square given to us, and I could ask you information about the element. So I could say, what's the symbol for this element? And you would look at this symbol over here and say, well, it's uppercase O, big O. What's the atomic number? It's the number at the top here, so 8. What's the mass number, or sometimes we'll call it atomic mass? 16. How many electrons does it have? Well, if we're assuming it's a neutral atom, unless I tell you otherwise, we're going to assume it's neutral. The number of electrons is just the atomic number, 8. And the number of protons is also just the atomic number, 8. The number of neutrons, you do have to calculate it. You simply do your mass, the bigger number there, minus the smaller number, minus the atomic number, gives you 8. They won't always be equal to like this all the time, 8, 8, and 8, for example, that they will be different sometimes. But understand that you do your mass minus your atomic number to give you your number of neutrons. And so using this, you're able to find all that information about your element. What I want you to also get is that this is just a box from a certain periodic table. Sometimes the boxes vary and the layout varies as well, but there's usually a legend that you can look at to see what information is provided. So let's go take a quick look at that. So if you look here, this is another periodic table. This is the one we typically use for our course here. You can see it's a similar layout. We do have the atomic number, names on top here this time though. Mass number is over here. And you have other information given to you to something called electronegativity, and we'll study that later on, and your symbols there as well. What I want you to notice as well is that the mass is written as a decimal here, and that's because in reality, there's different types of, let's say, iron or different types of mercury atoms. There's some that are heavier, some that are lighter, some that are in between. So this mass is actually an average of all those different types of mercury atom that exist. And it's the same thing for carbon. This mass here, this average mass that you see there is actually an average of the different types of carbon that exist. There's the heavy carbon, the light carbon, and the in-between carbon. And so we take an average of their masses, and that's what we put on the periodic table rather than just putting, the mass of the light one or the heavy one or the medium one. So that's why we typically have those decimal places. But when you're asked to calculate the number of protons, electrons, neutrons from a periodic table like this, just round either up or down depending on what's appropriate. So for example, I'd round down for the 12.01, but I might round up for the 39.95 of argon over here. So just keep that in mind as we're doing practice problems and you're using a periodic table like this. So you should be able to answer a variety of problems. Let's go over this one here. Find the mass of an element with 6 protons, 6 electrons, and 6 neutrons. And there's a couple ways you can solve this. Some students might say, well, there's 6 protons, so what I'm going to do is I'm going to go to the periodic table and find atomic number 6, because the protons is the atomic number. So atomic number's on top, carbon, okay? So that means the mass would be probably 12.01. True, you could do that, but you got to pay attention. Here I gave you all the information you need. And because I gave you all the information that you need, you just need to use that information to solve for the mass. Remember that mass is really your number of protons plus your number of neutrons. And so all you have to do is just take your number of protons, which is 6, plus your number of neutrons, which is 6, add them together, and you get 12. And the unit is typically AMU, atomic mass units, if you're dealing with one atom. So this is the atomic mass unit, the AMU. And you wouldn't count electrons in there because they don't contribute to that mass. Let's take a look at this one here. Write the symbol and name for the element with 6 protons. So in this case, it would make sense that you would go to your periodic table and you would say 6 protons means atomic number 6, carbon. So you could go and write that out. So we want the symbol and name. So we have C, and then the name is carbon. And that C is a big C. It's an uppercase C because it's a one-letter symbol. Write the symbol and name for the element with 9 protons. So you can try it out yourself. You can pause the video, try it yourself, but you'd probably go to your periodic table. 9 protons means that I have atomic number 9. So right here on top, 9. That's fluorine, F for fluorine. F, and it's fluorine. Write the symbol and name for the element with a mass of 39. So be careful here. Here we told you the element has a mass of 39. So let's go take a look at our periodic table. We told you the mass of 39. So that means that we're dealing not with the top number this time, we're dealing with the bottom number. So if you thought that we're dealing with the top number, you'd say that we have yttrium, which is incorrect because, again, we're dealing with the mass. Look at the mass. This is 88.91. So we need to look for a mass of 39. So whatever is closest to 39. This is 39.95. That would probably around the 40. This over here is 39.10. So this over here would be the element that we're looking for. It's potassium. Element symbol is K. So K, and then potassium. Write the symbol and name for the element with 14 electrons. Now, I want you to be careful here. Electron number can change, as can neutron number. Elements can lose and gain electrons. In this case, we're assuming that it's just kind of the neutral element with the standard number of electrons that it has. The subatomic particle that really tells you what element you're dealing with is the number of protons. That's the identifier. The number of protons really makes that element that element. So 1 proton is hydrogen, 2 protons is helium, 3 protons is lithium. And typically, for example, lithium, if it has 3 protons, would also have 3 electrons. But it could lose electrons. And so lithium could lose electrons, but it can't lose its protons. So lithium will always be identified by the number of protons that it has. So just keep that in mind when we're doing practice problems, that really it's the protons that determine what you're dealing with. But we can still do problems like this assuming they're neutral. So we are looking for something with 14 electrons. And remember that the atomic number tells you the number of protons, and in a neutral atom, the number of electrons. So 14 electrons, it looks like we're dealing with silicon. So right here, 14 electrons, silicon, Si. So let's go ahead and write that in. So Si, and then silicon. Remember, uppercase S, lowercase I.